G'day, I'm Yuki-san Dev, and in part 25 of the series Unity for the Absolute Beginner, we will make a start on our second game. Well, yep, it's game time again. So in this game, we will try to use everything in the beginner series so far, and more stuff that we haven't covered yet. We will make this game using the beginner jargon in my attempts to make it a little easier. Then after it's done, we will revisit it again to change certain areas that could be coded better and more efficiently. A little about the game. Well, this game I made a while back for my daughter, and I've since deleted the actual source for it, but I still have the partially compiled game so I can show you roughly what it would look like. It's a typical arcade retro style Space Invaders game with a Minecraft theme. Here is a brief gameplay of it. Well, that was very dramatic. A little anticlimactic hearing my voice now, probably. So we are going to build this game from scratch. I haven't planned this much, so it's pretty ad-lib, and there might be a little backtracking as a result, but we'll see how we go. All the images, wraps, models, and sounds, etc. will be available on my GitHub, and the link for that is in my description. I think the only thing I had to pay for was some particle effects. If so, I will mention it at the time and find some free alternatives. Not sure how many videos this will take, but I will take it slow, piece by piece. Today we'll get general things set up to start, and then we'll work on getting enemy prefabs in place with their wraps. We'll get our spawner system started along with the enemy script. And when I say get them started, I mean that of course these scripts we will revisit constantly throughout the making of the game as we progress. Also, these videos are probably going to be quite a lot longer than my usual video length throughout the series, but we'll see how we go. So let's get straight into it. Okay, so I have my hub open here, and I'm going to create a new 3D project, and I'm going to call it MineCraft Invaders. And if you want to use the same version of the editor, then it's this version right here. It might be a trick if you're following along to use the same version, because later on down the track I might use this game to show how to use splines, and splines in the older versions won't work. So let's create the project. Alright, so let's start the ball rolling by making a whole bunch of folders to hold all of our bits. So in your project window, make the following folders: audio, custom fonts, images, imported, materials, meshes, prefabs, and finally scripts. And under the scripts folder, I'm going to make another subfolder called gameplay. Alrighty, so first let's set the scene up a little. So drop scenes down in your project window and rename sample scene to gameplay 1. And now click on the main camera and change skybox to solid color. And change the color to black. And change the projection to orthographic. And now right click in your hierarchy and create a plane and name it background. And we'll do the usual reset, let's transform. And we're going to set Z position to 1. This is because everything else will be positioned at 0 or more. So this will avoid anything colliding with the background. And we'll rotate it minus 90 degrees on X. And lock XYZ in scale and scale it up to 1.5. Now click the 2D toggle so we can see the flat view of the plane. Alrighty, so if you are building this with me, then you will need some files which are available on my GitHub. The link is in the description. After you have the collection, you should see a file named space.jpg or JPG. Drag that into the project. Then drag it onto the plane. And then just drag that image into your images folder. Click the background plane and change the material shader from standard to unlit texture. That's better. Now we want to create another plane in the hierarchy as a child of background and name it right border. And reset its transform. Now you won't see it because it's right in or on the other plane that we made, so change its Y position to 1. And now we'll click on our rect tool and pair it up with the black space on the right border. It's kind of hard to see, but just pair it up over there. The transform numbers should look something like around these numbers here. And now drag in the border texture.jpg into the project. And then onto that right border. And click on the right border and change the material shader from standard to unlit texture again. Now copy that right border and paste another one under background and name it left border. And move it over to the left side to cover the black space. Now, just quickly, if you jump out of 2D mode, you can see that there's a nice gap between the two borders and the background. This is so the enemies can pass underneath without messing up the GUI. Alright, back into 2D. Okay, so let's get the background moving with our all familiar move script. So let's create a C# script in your gameplay folder. And name it move background. And drag it onto the background object and open the script. Alrighty, so let's just do a quick script in here to get the background moving. You remember back in part 14 of the series, we will move this background with texture offset. So starting with the variables, let's give our scroll speed a slider. So let's do range minus 1f and 1f. Serialize field. Private float scroll speed equals 0.5f. And then private float offset and private material matte. And let's assign the material component to matte and start with matte equals getComponent renderer.material. And then finally, let's get it moving. So in update, type in offset plus equals time.delta time times scroll speed divided by 10f. And then matte.set texture offset. And then in speech marks underscore main text, make sure you spell that right with the capitalization, otherwise it won't work. New vector 3. 0 minus offset. Cool. Alright, now let's save this. And if we click run to test it. Cool. And we also have our scroll speed slider so we can tweak the speed at any time. Alright, so our gameplay scene is pretty much set. It just needs a GUI, which we will cover later down the track. Now for the enemies. So I have some of the old model cubes that I made for my Blender series and other things. They will be in your pack if you downloaded my game files from GitHub. So drag in the MineCraft cube.fbx file into your project. Then click the prefab and extract materials. and accept the default location. Now click on the wrap material and change the shader from standard to unlit transparent cutout. This is so in the future if you use any kind of wrap with a transparency, then it will work better. Rename the wrap to default enemy wrap and drag it into your materials folder. Now drag the MineCraft cube object into the hierarchy and then drag it into your meshes folder. Alright, now click on the one in the hierarchy and let's name it enemy normal. Now when I made this I must have done something funky with the rotation, so set X rotation back to 0 and lock XYZ scale and size it down to 15. And while we're at it, let's just drag it up the screen a bit, set its position of Y to 5. Okay, so we aren't going to drag a texture onto this cube because we're going to do that in script this time, so we can use more textures and apply them randomly. So let's just give it a rigid body and set angular drag to 0 and turn gravity off. And now let's add another component, a box collider, and enable isTrigger. Shouldn't be any need to set the boundaries of the collider because they should have automatically wrapped around the mesh perfectly. And we're going to need a script for it, so let's attach one in a different way this time. Click Add Component and search for script. And then select New Script, name it Enemy, and select Create and Add. Then in the project window, drag the new script into the scripts gameplay folder. Okay, we are pretty much done with our enemy template models, so right click on enemy normal and select prefab and then select unpack. This is just to break the link between the original Minecraft cube we imported. And now drag that enemy into our prefabs folder to create a new prefab. Now copy the enemy normal in your hierarchy and paste 2 more of them. And name each one of those 3 to enemy shooter, enemy seeker, and enemy free mind. And now select all 3 of them and drag them into your prefabs folder, but this time select prefab variants. And then you can delete them from the hierarchy. So now we have 4 types of enemy. We've got enemy normal, which is the master with its 3 variants. So any changes we want to make to all the enemies can be done through enemy normal, and they will filter down to the variants. Let's put that theory to the test by adding a tag, which we will actually need later anyway. So click on enemy normal, select tag and add tag. Click the plus to add a field, type enemy and click save. Click on enemy normal again and drop untag down and select enemy. And now if you click all the other variants, they should all have the same enemy tag. Cool. Alright, one more small thing. Take out the variant names in the prefabs. We don't need to be reminded that they're variants. Alrighty, so I'm not going to use any inheritance for this game, so there will only be one enemy script, and that will control all the enemies. So firstly, let's get some textures on these cubes when they get instantiated and get basic movement going. But first we need some boundaries for the enemies to destroy themselves when they go off screen. So drag enemy normal from your project into the hierarchy. And now use the move tool to move to each edge and figure out the numbers. So the top looks like it's going to be about 6.5, bottom around about 4.2, and the right around about 7.7, which means the left will be minus 7.7. Cool. And delete enemy normal from the scene. Alright, so let's open our enemy script and get ready for some new stuff. Alrighty, so let's set a few variables here. First, we'll do a force one, so let's make it serialized so that we can change it in the inspector. So serialize field private float force equals 1.5f. And we're going to need the renderer and rigid body, so private renderer rend. And on the same line, we'll do private rigid body enemy RB. And we're going to need an array to hold all of our textures, so public texture and texture. And the two empty square brackets, of course, are to make it an array. And then the boundaries we just figured out earlier, so private float enemy boundary x equals 7.7f, enemy boundary y top equals 6.5f, and enemy boundary y bot for bottom equals minus 4.2f. Now these numbers might differ from yours, but they should be around about the same if you are following along. Cool, now let's retrieve the two components into our variables. So in start, type in rend equals getComponent renderer, and enemy RB equals getComponent rigid body. Alright, let's get these guys moving and spinning. So enemy RB dot add force vector 2 down times force, and we'll make force mode impulse. And enemy RB dot add torque 1, 1, 1. Actually, let's make the torque a bit more random, so let's make a quick function. Private float get random torque, and then we'll have it return random dot range between 10 and 15. And now replace the last two ones in our torque line to get random torque. Cool, now the enemies will move down the screen at the speed of force and spin at random speeds. Alright, in update, let's put our destroy boundary limits in, so the enemy will destroy itself if it goes off the screen. So there's a nice big line here. If transform.position.x is smaller than minus enemy boundary x, or transform.position.x is greater than enemy boundary x, or transform.position.y is greater than enemy boundary y top, or transform.position.y is smaller than enemy boundary y bot. It's a pretty long line. Then in the curlies, destroy game object. And now lastly, we need to give the enemies textures. So let's make a new function and call it set random texture. And in the curlies, type in int index equals random dot range, and it'll be between 0 and the array texture dot length. And then rend dot material dot set texture, and underscore main text and speech marks. Make sure you get the spelling right and the capitalization right. Texture, and then the index. So we have a local integer variable named index, and it will hold a random number chosen between 0 and however many textures are in the array. And then we're using set texture to assign the wrap to the cube. Alright, now all we have to do is call that function and start with set random texture. Alright, I think we're all set with the script for the time being, so let's save it. Now, from my pack that you've got from GitHub, drag the entire QWraps folder into the images folder in the project. And now we're going to distribute these images to their respective enemy types. Don't worry about the boss folder, we will do the boss later on. So we will do enemy normal last, because if we do it first, then all of the textures will filter down to all the variants, and we don't want that. So let's do the shooter prefab first. So click on the enemy shooter prefab, and drag the TNT image from the shooter folder into the word texture in the script component. And now do the same with the seeker and drag the creeper pumpkin out of the seeker folder into the texture slot. And then do the magma block for the free mind. Alright, and lastly click the enemy normal prefab, and then just up here click the little padlock to lock it. And this will make it so that it can't be deselected, so that we can select something else. Then select all the normal enemy images together and drag them onto the texture word. And now click the padlock again to unlock it. Cool, so now click each prefab to make sure they all have their own textures. Sweet, so now if we run this, and if we drag some enemies up into the hierarchy, they should all have textures, and the normal enemies will be random textures from the ones we dragged in, and they should all be getting destroyed when they reach the bottom of the screen. Alright, so that'll do it for the enemies for now. We still need to script each enemy's abilities and other stuff, but we will get to that later. Okay, so the next part to get started is the spawner. The two main scripts that will control this game will be the spawner and the game manager. The spawner will contain all of the wave bits and pieces, so let's set up that basic system now. So let's create an empty object in the hierarchy and name it spawner. And let's make a script with the same name. And drag the script onto the spawner object. And open the script. Alrighty, so get your thinking caps on for this one, because there's some more new stuff in here. So to get this up and running temporarily, we're going to have to do the script a little differently, and then later, after we put the game manager in, we'll change things in here a little. But this is just to get our waves and positioning and things like that set up. This is some new stuff, so take your time. Alright, so we're going to need a nested class here because we want to have wave-specific info, but we also want to have multiple waves. I'll explain this after we've actually done the code. So let's do system serializable, and then public class waves, and a couple of curly brackets. Then in between the curlies, type in public game object, and then 2 square brackets enemy, and then public int next wave score, and then public float spawn rate. Alright, that's our nested class. So now outside that class, in our spawner class, type serialize field private waves, and then 2 empty square brackets wave, and then private int wave number equals 0, comma wave limit. So it's basically 2 variables on one line. And private float spawn boundary x equals 6.94f, comma spawn boundary y equals 6.2f. Alright, so we've created a nested class called waves. It contains wave-specific info for each wave. It has an array called enemy, which will hold any game objects that you want to use in the wave. It has an integer next wave score, which will be what score is required to start the next wave, and the spawn rate, which will be used to set how fast objects spawn in the wave. Then in our spawner class, we are creating an array of waves, so there can be more than one wave. Then a couple of integers, one for wave number, this is to keep track of the current wave in progress, and wave limit, which will hold the length of our wave array so we know when the end of all the waves happens. This will all make a little more sense once we get into the inspector and actually use it. Then there are spawn boundaries. Y is set to 6.2, so it spawns off the screen at the top, and the X boundary will be used for generating a random X spawn location between -X and X. So it'll come down in random locations from the top. For now, let's just save this and get back into the editor. Now, don't worry about the errors right now. They're just there because we have declared variables that aren't used yet. So click on the spawner in the hierarchy, and in the inspector enter 3 for the amount of waves up here. Now if you drop down each element, you will see that each element has its own set of rules. That's the nested class. And inside that class is another array for the enemies. So for starters, let's drag enemy normal prefab into the enemy slot for the first element. Then in element 1 of wave, enter 2 for the enemy count, and drag enemy normal and enemy shooter into the empty slots. And then in element 2, enter 3 for the enemy count, and drag in enemy normal, enemy shooter, and enemy free mind. So each of these elements has its own little enemy pool, which our spawner will use to spawn from. So when playing the game as it currently is, in wave 1 you will only get normal enemies, in wave 2 you will get a mix of normal and shooters, and in wave 3 you'd get a mix of the normal, shooters, and free minds. Now each element has its own spawn rate, so you could have enemies spawning faster as you progress through the waves to make it harder for each wave. For now, let's just set each one of those to 1. And then finally the next wave score, and this will be used to set the score required before the next wave starts. So for now, let's just set low numbers for testing, and we'll change them later. So let's do 5, 10, and 15. Alright, let's now jump back into our spawner script. Okay, so as I mentioned earlier, we will need to set this up temporarily for testing, and then we'll change it later once Game Manager is handling things. So first off, in start, let's get the length of our wave array with wave limit equals wave.length. This, of course, will be however many waves we have created, so right now it will be 3. Now let's make a quick function to get a random spawn location for each enemy spawned. So private vector3 random spawn location. And in between the curlies, type in return new vector3 random.range, and the range will be between minus spawn boundary x and spawn boundary x, comma spawn boundary y. Alright, and now we can set up our coroutine to actually do the spawning. So the waves will be based off the player's score, but since we haven't set that up yet, and we would like to test our system out a little, we can just use the enemy count. So let's temporarily set a variable up here with private int enemy count equals 0. And now let's do our coroutine. So we'll do the code first and I'll explain it afterwards. So IEnumerator spawn waves, and in between the curlies type in while enemy count is less than wave, and then in square brackets wave number dot next wave score, and then between those curlies type in this. I'm not going to read it out as I type it because it's rather cryptic. And then underneath that type in enemy count plus plus, and then yield return new, wait for seconds, and then wave, and then in square brackets a 0 dot spawn rate. Now outside of that while loop, type in wave number plus plus, and now we want to check if there is any more waves after this one is done. So let's do if wave number is less than wave limit, and in between the curlies type in yield return new, wait for seconds, 0.5f, and then start coroutine spawn waves. And lastly, outside the if curlies, type in else debug.log, and then in speech marks all waves done. That's just temporary. Alright, let's go through this. So our while loop is going to keep looping while enemy count is less than the next wave score. And it's getting that next wave score from each wave in the class waves. Remember we set them to 5, 10, and 15, right? So this while loop will run until it reaches 5, for instance, for the first wave. Then the instantiate line is going to choose a random enemy from the array of enemies, and instantiate it at a random X location. Then we will add 1 to enemy count, and then finally wait for the amount of time that we set in spawn rate. So the running of the while loop for the first wave would look something like this. Alright, and now after the while loop reaches the end and exits, we add 1 to the wave number. Then the if statement is checking to see if there are any more waves. If there are, then restart the coroutine. And of course the wave number has increased by 1, so it will use the second wave's info in waves class. And then if the waves are all done, for now we just have the output to the console to say all waves are finished. Actually, while we're at it, let's put a debug up here as well to tell us what wave is spawning each time the coroutine runs. So before the while loop starts, type debug.log and speech marks running wave, and then plus wave number. Alright, so now all we need to do is kick off the spawning process by starting this in start. So type in start coroutine spawn waves. Also, throughout this game I will be making use of these collapse and expand toggles here on the left. They will collapse or expand anything basically in curly brackets. When scripts get big, it's quite a nice feature to use. If you put your rem statements on the end of the function or method, or the ifs, then when you collapse it, it's easier to know what's inside. Okay, so I think we're ready to test this all out, so let's save. And let's run it. Alright, console is showing the current wave being spawned. It gets to 5 and moves on to the next wave. Enemies all destroyed themselves when they got off the screen. And gets through all 3 waves and stops with a message, all waves done. Cool. And if I run this again, you can see that wave 1 is only spawning enemy normals because that's all it has to choose from. And wave 2 is a random mix of normal and shooters. And wave 3 is a mix of normal, shooters, and free mines. Cool. Of course, this can be altered at any time by adding or removing enemy game objects from those slots. Alright, now let's set up the enemy's special abilities. So 1 or more enemies are going to fire bullets, so first of all let's make a bullet prefab. So right click and create a capsule in your hierarchy. And name it enemy bullet. And we'll do our usual reset transform. And let's lock XYZ scale and resize it to 0.05. And let's also give it a rigid body and turn gravity off. Not sure that we're going to use the rigid body, but we'll put it there anyway. And jump into the collider and enable is trigger. And let's create a new tag for it. And we'll name it enemy bullet. And apply it to the bullet. Now let's make a new material in the materials folder and we'll name it red. And change its color to red. And drag that material onto the bullet. Click the bullet and change its shader to unlit color. Alright, it's going to need a move script, so create a script in the scripts folder and name it enemy bullet. And drag it onto the bullet. Okay, let's open the script and get this thing moving. Okie doke, so we will need a destroy boundary, so when it leaves the screen it gets destroyed. We can use the same boundaries as the enemy boundaries, so private float destroy boundary y equals minus 4.2f. And we need a speed variable, so serialize field private float speed equals 2. And let's take the start method out, we won't need that. Now in update, let's move it with transform dot translate vector3 dot down times time dot delta time times speed. And let's put our destroy condition in there. So if transform dot position dot y is less than destroy boundary y, and then in between the curlies, destroy game object. Okay, let's save this. And a quick play. Yep, bullet moving, and when it gets off the screen, it destroys itself. Cool. And of course, we can tweak the bullet speed at any time here. All right, drag the bullet into your prefabs folder to make the original prefab, and delete it from the scene. Okay, now let's get into the enemy script to set up the special abilities. Alright, so our enemy script is going to need a reference to that bullet we just created so that we can use it. So in our declarations, let's do serialize field, public, game object, bullet. Okay, well, we might as well do the shooter first, so let's make a coroutine for the shooter to fire bullets. So down here, let's do IEnumerator, fire bullets, and a couple of curly brackets. And in the curlies, let's do while true, and in those curlies, yield return new wait for seconds, and we'll do a random dot range between 1 and 4. And then instantiate bullet, comma transform dot position, comma bullet dot transform dot rotation. So this will run for as long as the shooter enemy exists, and it will wait anywhere between 1 and 3 seconds per loop, and then instantiate a bullet at the position of the shooter, and the bullet will keep its original rotation. Alright, now let's start setting up some cases for when to run these special abilities we are creating. So in start, let's do switch, and then this dot name, and a couple of curlies. And in those curlies, type case, and then in speech marks, enemy shooter, and then in parenthesis, clone. And then start coroutine, fire bullets, and then a break. Now, I don't know if I've mentioned this before, but this dot name is referring to the name of the object that this script is attached to. Also, when these enemies get spawned during gameplay, they will have clone in brackets next to them. So in this case, if the object name happens to be enemy shooter, clone, then start the routine we just made, fire bullets, and then break to end the case. Alright, before we do another one, let's test this one. So let's save this, and click on the enemy shooter prefab, and drag the enemy bullet into our bullet field that we just created. And now, just to make things quicker, let's click on the spawner object and replace enemy normal with enemy shooter for the first wave, just so they spawn straight away. And run. And there we go. Shooters are randomly shooting. Alright, let's get back into the script and do another one. Alrighty, so we'll do the free mine next. So this guy is just going to randomly go where he pleases. It needs to be able to move up, down, left, and right. So let's make a function for this one. So private void random move. And in the curlies, let's make a temporary integer for a random number between the 4 directions that it can move. So int states equals random dot range between 0 and 4. And now let's make a switcher. So type switch states and a couple of curly brackets. And now let's do case 0 and enemy rb dot add force vector3 dot down times force, and force mode impulse. And then a break. And now we can just copy from case 0 down to break and paste 3 more of them. And just change the case numbers to 1, 2, and 3. And then change the vector 3s to up, left, and right. So you have the 4 directions. Alright, so this function will choose a random number between 0 and 3. And then depending on what number it gets, it will run the related case. And now we need to get this into the enemy specific switcher up here. So let's do case enemy freemind clone. And then invoke repeating random move and 2, 2. And then a break. Cool. So if it's a freemind object instantiated, then it will wait 2 seconds. And then every 2 seconds after that, it will change direction. The reason we're waiting for 2 seconds initially is to give the script before it a chance to get the cube into a visible position on the screen. Alright, so let's save this. And again, we'll click our spawner. And in the first wave, change the enemy shooter to enemy free mind, just so they spawn immediately. And run. Sweet, they're all doing their thing. Alright, so the last one is the seeker. It's going to head in the direction of the player, but we don't have a player in here yet, so let's just put a placeholder in the script to do it later. Now it's probably going to be a coroutine, so let's do IEnumerator, follow the player, and a couple of curlies, and then yield return null. And then up in our enemy specific cases, let's do case enemy seeker clone, and then start coroutine, follow player, and a break. Cool. So right now, if a seeker is instantiated or spawned, it will start the coroutine follow player, which will for now do nothing. We will put this in when we actually have the player. Alright, so let's save this. Alrighty, so I think that will do for phase 1 of this game. So let's do a recap. So we created our gameplay scene with side borders for the GUI and a scrolling starfield background. We have imported and set up our enemy prefabs using just one mesh from Blender, and we're using multiple wraps to decorate them. And we started on our enemy script for the enemies to use. It starts with the code that all enemies will follow, and then we have a switcher to run enemy specific tasks. And we've started our spawner script off as well with a wave system and a temporary coroutine to test it out. So I'm just going to do a quick slideshow here of the scripts we did today with added rem statements for you to double check, and it might make things easier to understand. In the next video, I think we will get the player in with a free asset from the store, and we'll script the movement and the firing of the player. And since we have a player, we can also script the seeker ability in as well. And after that, we'll see what else we can fit into the video. There's still quite a lot to do. I will try to get it out as soon as possible, but in the meantime, make a copy of the game that we've done so far and have a play around. Maybe think of a different type of enemy you could slot in there. You would just need to make a case for it and a set of instructions for it to follow. So I hope to see you in the next installment of this game.